Hey everyone, this video is going over inverses of functions. So one thing to keep in mind that every equation has an inverse, but not every inverse is a function. So I want you to think back all the way to one of the first things that we talked about. Is the graph a function? So typically we would use the vertical line test to determine if a graph is a function. Well, since we're doing inverses, and inverses means opposite, we're going to use the horizontal line test. So I'm abbreviating, but you might want to write that down. If a graph passes the horizontal line test, the inverse is also a function. So this is cubic. And you can tell any horizontal line that I draw will only pass through once. So that tells me that the inverse is a function. And the inverse is a reflection over the line y equals x. So it's going to be like a diagonal line of symmetry. So it's going to look something like that. And if you have an exponent, the root is the opposite operation. So this is actually what a cubed root function looks like. Now, because this is actually a function, I'm going to use this notation to symbolize that it's an inverse. That's what the little -1 is indicating, that what you're looking at is a function and it's the inverse of the original function. So that's what the little -1 is a symbol for. All right, now we can't use that for every single problem because not every single graph is going to be a function, but it will still be an equation. So for example, this is a parabola. So the equation is y equals x squared. This does not pass the horizontal line test. So that means the inverse is not going to be a function. And if I reflect this diagonally across that line, it's going to look something like that. All right, and so that is the square root, but one thing that we don't always remember or don't always talk about is whenever you take the square root, you have to consider the positive and negative outcome. So technically, the inverse graph of a parabola is not a function. It's not a square root function. It's actually just like a sideways parabola. So for this example, I would not use this notation because this is not a function. And you can tell this now, the pink one that I drew fails the vertical line test. So this one would not be a function. So we would not use that notation. So a lot of times what you're going to see, especially with parabolas, you might see a little inequality next to the equation, and all that does is it restricts the graph so that we don't run into this problem. So basically, I would only use that half of the parabola, and then it would only be that half of the inverse, which is what the square root or radical function looks like. So that's just a notation thing, and it's the only purpose of having an inequality to restrict the graph is in order to make the inverse a function. So don't be alarmed if you see some of that notation. It's not going to affect how you do the work. It's just going to affect the graph. All right, so inverse means opposite, and we're going to do opposite operations, but we also have to work backwards from the order of operations. So we're actually going to look for addition and subtraction first, then we'll look for multiplication and division, then we'll look for exponents, and then we'll see what was inside parentheses. So we're actually going to be going in reverse order. So one thing that I like to do when I'm teaching students how to do this for the first time is start with a do-undo list, because that will force you to identify the operations and make sure you are actually doing the opposites and that you don't leave anything out. I will show you kind of like a step 1, step 2, step 3 type of way also. Ultimately, I have no preference as long as it clicks with you one of the two ways. So a do-undo list, you have to identify all the operations that are happening to the x in, please excuse my dear Aunt Sally, order. So I know that this means multiplication, and I can see here clearly that that means add 6. So in the correct order, I would do the multiplication first. And then I would add 6. So the opposite, divide by 2 and subtract by 6. So when you are following your undo list and we are working backwards, I actually need to start from the bottom and work my way up the undo side of the list. And so what I'm going to do is actually just write the letter X, because ultimately my end result is going to be y equals X, and it's going to be a new equation, and it's going to be the opposite of everything that's in this original function. So the first thing that I'm going to do to my X is at the bottom of my undo list, and that is to subtract 6. After that, it says to divide the whole thing by 2. And that's it. And so when you are building your new inverse equation, it's important that you realize that you're probably not going to be able to simplify anything, and it's almost like you're building a Lego tower. Like each new step is just going to build on top of what you already wrote. So you just have to make sure as you go up the list, you should have an equation that looks like it's getting bigger and bigger. And you can simplify that if you wanted to. That would be 1/2 x minus 3, but either way, it doesn't matter to me. So I will show you another way, and ultimately it's doing the same thing. It's just a matter of how you visualize it. So a lot of times we start by swapping the x and the y variable, because basically what I'm trying to do is isolate the y, and we work from outside in, and that's because usually the addition and subtraction, or the stuff that's towards the end of the list, is furthest away from the variable. So if I wanted to isolate y, I would have to subtract 6 on both sides. So this side, I cannot combine. Those are not like terms. So that new expression is just x minus 6. And then I would divide by 2. So y is isolated, and I still have x minus 6 over 2. All right, so either way, I have no preference. All right, so the next one, if I think about the operations that are there, I do have something in parentheses. So anything in parentheses, I would do first. And then I have an exponent. My expression is being squared. So the opposite of plus is minus. The opposite of square is square root. So this is another important thing to remember, that if you have an equation that starts with a radical in it, that counts as an exponential step. So a square root or a cubed root or anything radical counts as an exponential step. And please excuse my dear Aunt Sally. All right, so I'm going to follow my list from the bottom up. So I'm going to start with x. I am going to take the square root of x because that's on the bottom of my list, and then I am going to subtract 2. All right, and that is my inverse. I can't simplify that at all. If you wanted to do it without making a list, we're going to do it the same way. Typically, your instructions tell you to swap x and y. And we are going to isolate y, starting on the outside and working our way in. So first, I would have to take the square root, because everything is like trapped right now by the exponent. And now I can subtract 2. All right, and once you flop the equation around, it is the same. All right, guys, and keep in mind, you can pause the video, you can go back and rewatch it. I'm going kind of fast because I want to make sure I show you at least 3 examples. All right, so the next one, we have a fraction, and so I'm going to show you 2 ways. I don't care which way you do, whatever makes the most sense to you. The first way I'm going to show you is kind of the longer way. So whenever you have a fraction, you can think about that as a multiplication step and a division step. Because basically what this means is 2 times x divided by 3. All right, and then I also have addition. So please excuse my dear Aunt Sally, I just start with what's on top. Technically, multiplication and division, neither one comes first, but because of the 2 being in the numerator, I like to start with that. So times 2 divided by 3 plus 4. I have my multiplication and division, and then my addition or subtraction. I'm going to do the opposite. All right, and as I'm working, I'm going to start on the bottom and work my way up. So I'm starting with x, I'm subtracting 4. Now I need to multiply this entire quantity by 3. So I'm going to have to put it in parentheses to symbolize that I'm not just going to multiply x by 3. I need to multiply the entire expression that I currently have, which is x minus 4. I need to multiply that whole thing by 3 and then divide by 2. All right, and that is my inverse equation. To simplify these as a step, since you're multiplying by 2/3, you could always get rid of it by multiplying by the reciprocal. So what that would look like, that would just basically be one step. You would multiply by the reciprocal. I would still have that plus 4 minus 4 on the bottom. So basically it would look the same. I would still have x minus 4, but then I would just multiply that entire quantity by 3/2. And so these two are the same. So it doesn't matter if you move the 2 as a denominator just for the 3, or if you draw the big line like that and show that you divided the whole thing by 2, they mean the same thing. All right, and again, just to show you, if you didn't want to make a list, that's fine. Swap x and y. Oh, I forgot to swap. All right, and we're going to start with what is furthest away, which means we're going to subtract 4. All right, we're going to multiply by 3 to cancel out the denominator. We're going to divide by 2 to cancel out the numerator, and so we get the same thing. Alrighty?